Okay, sorry there was stuff on the screen, but okay, so you've got a worksheet on substitution, and so you've got to be able to do the process, and you have to be able to identify whether there's one solution, infinitely many solutions, or no solution. So, a couple of things going on. Number 22, well, let me get to be able to draw. All right, number 22 has 7x plus 2y is negative 13, and negative 3x minus 8y is negative 23. Okay, this is, and I'm sorry, that didn't show up. This is not a good system for using the method of substitution, because you have to use substitution, you either have to have an x equals equation or a y equals equation so you can substitute it in the other one. Neither of these is going to be easy. I'm going to go ahead and take the first one, and I'm going to take 7x plus 2y is negative 13. And although it's going to be unpleasant, I'm going to solve for this y. So I'm going to subtract 2x, subtract 2x, I'm sorry, 7x. That leaves me with 2y is equal to negative 7x minus 13. Divide by 2, divide everything by 2. I don't know what those little zeros there were. Y is equal to, okay, having trouble. All right. Y is equal to negative 7 over 2x minus 13 over 2. Now, this let me change something. It quit drawing. All right, this is a value for y, and I'm going to plug it in the other equation. So if you remember looking at my work before, when you're supposed to substitute, then I draw that arrow. I have negative 3x minus 8 times negative 2/7 x minus 13 over 2 is equal to negative 23. All right, this is kind of yucky. So I have negative 3x. I need to distribute. This is going to be negative times negative is positive. This 2 divides into this 8, making it 4. So 4 times 7 is 28x. Then I have to multiply here, and I have negative 8 times negative, and it's negative 8 over 1, times negative 13 over 2. Negative times negative is positive. The 2 goes into the 8 4 times. 4 times 13 is 52. And that's just the whole number, 52, is equal to negative 23. So I had to solve one of the equations for either x or y. This one I would have had to divide by a 7, the x. The y up here, I'm up at the top. I thought my pen would show something. Hold on, let me look. But it's not going to. All right, so I could solve for this x. I could solve for this y. I could solve for this x. I could solve for this y. I chose this y just because I thought dividing by 2 would be the best. Plugged it into the other equation in the place of y. Each time I had negative times negative, so those became positive. Each time the 2 divided into the 8 4 times, so it was like 4 times 7 for 28 and 4 times 13 for 52. If I combine my x's, I have 25x plus 52 is equal to negative 23. Now I can tell right now that I'm only going to have one solution because I am going to be able to solve for x. So let me subtract 52 from both sides. and I have 25x is equal to negative 75. Well, that's a surprise. It's going to go in there evenly, divide by 25, and x is negative 3. So unless I've made some kind of oops, I'm not finished. That's x. So now we need to find y. I always use the equation that I've circled. So I have y is equal to negative 7 over 2 times negative 3 minus 13 over 2. So y is equal to negative times negative is positive. That's not going to divide out, so it's positive 21 over 2 minus 13 over 2. So y is equal to 8 over 2, which is 4. I honestly didn't expect such a nice answer. Negative 3 comma 4, one solution. Now let me look at these problems and see if I can see one, and I can show you what it looks like for no solution or infinite solutions. All right, I decided to pick number 24. It just has a look to it. It is very difficult, even for someone with a lot of experience, to know which category a problem is in without starting to solve it. All right, number 24 has that for the first equation, and y equals 4x minus 5 for the second equation. I'm going to take this one. I solve for x, and I'm going to take this and I'm going to put it in the place of x. It looks kind of yucky, but I think it's going to be okay. So when I substitute, I have y is equal to 4 parentheses y over 4 plus 1 minus 5. Okay, so I've taken the first equation, which was solve for x, and plugged it in the place of x in the second one. So I have y is equal to, when I use the distributive property, for the first one, the 4's divide out and I just have y, and then when I distribute, I have a 4 there and a minus 5. Now, when I try to get my y's on one side, it turns out that all of the y's disappear. And if I combine those, I have negative 1. When the variables drop out, when you're trying to, after you've done the substitution and you're trying to solve, then you've got one of the two weird cases. When the statement that you have with no x's and y's, they're gone. When it is false, because 0 is never equal to negative 1, your answer is no solution. When it drops out and the resulting statement is true, like 5 equals 5 or 0 equals 0, then you have infinite solutions. Let me see if I can find one of those. All right, I'm going to do 27, but I don't promise it's going to work out like I want it to. I'm trying to do this rapidly, so I haven't solved it to know for sure, but this is number 27. So 3y is equal to negative 3/2 x plus 9. Now, it's not real pretty to solve for any one of these 4 variables, but I think I'm going to solve for this x. So I take this equation, 3x plus 6y is 18. Subtract the 6y. I have 3x is equal to negative 6y plus 18. Divide by 3. And I have x is equal to negative 2y plus 6. Not that bad. Take that. Let's put it in the place of x in the other equation. So I have 3y is equal to negative 3 over 2, open parentheses, negative 2y plus 6, close, plus 9. All right. So I have 3y is equal to Multiplying here, putting this over 1, I have negative times negative is positive. The 2's would cancel out, and I will end up with positive 3y. Then I multiply here. I am multiplying a negative times a positive, so I will get a negative. 2 goes into 6 3 times. 3 times 3 is 9. Then plus 9. When I simplify, I have 3y is equal to 3y, and those have canceled out. Now, remember that you might be tempted to divide by 3, but don't do that. You need to get all your y's on the same side. So if you subtracted 3y to eliminate it from the right, and you did that on the left, you end up with 0 equals 0. The variables are gone. But this is a true statement, so this has infinite solutions. So the things that I hope you took away from this is, first of all, you always have to pick one of the variables in your original equations that you choose to solve for. Once in a while, like on number 30, I see something that says x equals. On number 29, there's a y that would be easy. 26 doesn't look bad. So some of them are pretty straightforward. When you do this substitution step, right down here at the bottom, when you are trying to solve for the first variable, if the variables drop out, then you are either in the no solution or infinite solution category. And that, like this first one, they didn't drop out. You actually could solve. But in 24, they dropped out, those y's dropped out, and you got a false statement, no solution. And in the last one I did, they dropped out, but you had a true statement, so it was infinite solutions. I hope this helps a little bit.